This video we want to find the x and y intercepts of the graph of rational functions. Whenever analyzing the graph of a rational function or trying to find points on the graph of a rational function, it's a good idea to keep in mind the domain restrictions. Here I think pretty clearly the only x value that makes the denominator equal to 0 is going to be a -1. If you don't see that, set the denominator equal to 0 and solve. But that in mind, let's go ahead and find the x-intercepts. Recall that the x-intercept of a graph is where the graph crosses the x-axis. The y-coordinate of any point on the x-axis is 0. So when we want to find x-intercepts, we make our y equal to 0. Right? In other words, we set our function equal to 0 and solve. Now, a fraction is going to equal 0 only if the numerator is 0. That is always going to be true. To see that, multiply both sides by the denominator. Well, multiply the right side by x cubed plus 1, we're left with x squared minus 4. If we multiply the left side by x cubed plus 1, well, anything times 0 is 0. So if we set a rational function equal to 0, we are always going to get to the equation where just the numerator is equal to 0. So usually we just start our analysis at this line. But that being said, let's continue. Add 4 over and apply the square root property. We get two x-intercepts, positive and -2. Both of these are in our domain, so those are the two x-intercepts. Let's move on to y-intercepts, or intercept rather, right? Because a function can only have one y-intercept, if any at all. A y-intercept is where a graph crosses the y-axis. So the x-coordinate is going to be 0. So finding y-intercepts, we just compute f of 0. As long as 0 is in the domain. 0 is in the domain here, so we should be able to come up with a value. 0 squared minus 4 over 0 cubed plus 1. We get a y value of -4 for the y-intercept. Let's look at another one. Here's another rational function. Suppose we wanted to find the x-intercepts. Again, we know that x cannot equal -2 since it makes the denominator equal to 0. So with that in mind, let's proceed to find the x-intercepts. Set our numerator equal to 0 and solve. The solutions to this equation are positive and -2, but -2 is not in our domain. So x equal to 2 is the only x-intercept for this function. Notice that this is one of those reducible rational functions, which explains why only one of these is an actual x-intercept. Y-intercepts. Again, 0's in our domain, so we're going to go ahead and plug 0 into our function. we get 0 squared over 0 plus 2, which is a negative 2.